So good morning to all. So today we are going to discuss about thermal power plant. Thermal power plant, a significant source of energy. Okay, so let's begin. A thermal power plant converts the heat energy of coal into electrical energy. Thermal power plant converts heat energy. Here the input is heat energy. Heat energy means coal. Coal is converted. Coal produces heat energy, and it is converted into electrical energy. Coal is burned in a boiler which converts water into steam. Coal. Here is a boiler in which coal is burned, which converts water into steam with the help of heat energy. Okay. The expansion in turbines produces mechanical power, which drives the alternator coupled to the turbine. Expansion of the steam. The expansion of the steam. Turbines produces mechanical power. Turbines are rotated with the high pressure of the steam. Then turbines are rotated at very high speed. This is done by mechanical energy. This is known as mechanical power, which drives the alternator, which is attached to the turbine, which is coupled to the turbine also. Which is coupled to the turbine, and turbine produces electricity. Okay, let's see. Layout of thermal power plant. Here you can see coal supply. Coal supply is going to the transferred to the boiler, and here is the water supply. Water is transferred to the condenser. Condenser transfers the water to the boiler, and here the combustion process is going on, and water is heated and it is converted into steam, and there is a steam line where the water is converted into steam, and steam goes to turbines here, and turbines are rotated with the high pressure of the steams, and it is again the turbines is attached with the generator, which is alternator, and the generator works when turbines rotated, and it produces electricity. Electricities are transferred to transmission lines to the transformer, and transfers the transformer generator transfers electricity to the transformers, and transformers transfers electricity to transmission lines. Okay, here. Pulverizing plant. Okay, in modern thermal power plant, coal is pulverized, that is grind dust like size and carried to the furnace in a stream of hot air. Okay, so when when new coal comes to the power plant, it is not in sometimes some coals are larger in shape, where some coals are smaller in shape, so we can't burn all big size coals, so we have to pulverize them. Pulverizing it is a process where the coal is crushed into fine powder. Okay, it is crushed in fine powder so that the combustion should be complete. So pulverizing is means of exposing a large surface area to action of oxygen and consequently helping combustion. Okay, and pulverizing mills are further classified as contact mill, ball mill, impact mill. So let's go to the next page. Here is the boiler, working of the boiler. You can see here air and fuel inlet. Here air and fuel is in, and here is the water inlet. Okay, so here the water is going to this, and the combustion is going, and the fire is here, and the water is heated here, and then it goes to this container, and here the water is very heated, and here the steam is going to the steam outlet, and the steam is here. Okay, and this is working of boiler. Okay, in power plant. Boiler or steam generator is a closed vessel in which water under pressure is converted into steam. Boiler is a steam generator. It is a steam generator. I have already told you, in boiler the steam is generated. In the previous diagram, you see that the steam is the main output is steam. Okay, so here it is said that it is a steam generator. Okay, it is a closed vessel in which water under pressure is converted into steam. It is one of the major components of a thermal power plant. It is one of the major components. Okay, without steam we can't run thermal power plant. Always designed to absorb maximum amount of heat released in the process of combustion. So it is always designed to absorb maximum amount of heat released in the process of combustion. Okay, and boilers are of two types: fire tube boiler, water tube boiler. Turbine. A turbine converts heat energy of steam into mechanical energy and drives the generator. Okay, turbine converts heat energy. Heat energy is the coal. Coal gives us heat energy to steam into mechanical energy in the turbine and drives the generator. Then it coupled with the generator, turbine and the generator drives the generator. It uses the principle that steam when using from a small opening attains a high velocity. Turbines, I've already told you that turbines are rotated at very high speed. Okay, this is high velocity. Okay, the difference between initial and final heat content represent the heat energy converted into kinetic energy. The difference between initial and final heat, okay, represent the heat energy converted into kinetic energy. Heat energy is converted into kinetic energy. These are two types: impulse turbine, reaction turbine. Okay, now here is the turbine. You can see this is a turbine here, and here the steam rotates the turbine, which is coupled with the generator, and it has a magnetic field around the generator, and here this is the coil wire which produces electricity. Then wire transfers this electricity, okay, in the turbine, and this is the actual picture of turbine. Okay, and now cooling towers. Cooling towers is a steel or concrete hyperbolic structure having a reservoir at the base for storage of cooled water. So cooling tower is a steel concrete. It is made up of steel and concrete hyperbolic structure having a reservoir at the base. It has a reservoir where the cooled water is stored. Okay. Height of the cooling tower may be 150 meter and diameter of the base is 150 meter. Now let's go back. This is the actual pictures of cooling towers. Okay, these are the cooling towers like this and there. Now this. Okay, economizer. Fuel gases coming out of the boiler carry a lot of heat. Okay, flue gases coming out of the boiler carry a lot of heat. An economizer extracts the part of his heat from the flue gases and uses it for heating feed water. Economizer, what does economizer do? It extracts the part of the heat, extracts the heat energy from the flue gases and uses it for heating feed water. It extracts the heat energy. It takes the heat energy from the flue gases, and then it uses its heat energy to it reuses the heat energy to feed water. This use of economizer resulting in saving coal consumption and higher boiler efficiency. Okay, use of this method of economizer is leading to saving coal consumption of higher boiler efficiency. This is a diagram of economizer. Here you can see this is a feed water tank, feed water line. So here is the chimney and here is the economizer. Okay, feed water line goes feed water here, and the economizer takes down the all heat energy from this flue gases. The flue gases go. The economizer takes down all the heat energy, and transfers this heat energy to feed water line to the boiler so that it can be reused. Okay, so let's go ahead. Here, preheat to chimney via precipitator. It is precipitator via precipitator. Okay, The working of precipitator is to purify the gases which is released in the atmosphere. First releasing the atmosphere. So here you can see the boiler where the flue gases is here. Flue gases go to the superheater, then superheater to the economizer. To economizer goes to the air preheater. Air preheater. Okay, and this go on to the chimney via ESP. Generator and transformer and alternator. I have already told you generator is also known as alternator. Alternator, electromechanical device that converts mechanical energy to alternating current, electrical energy. Most alternators use a rotating magnetic field in principle of any AC generator can be called an alternator. Okay. Transformers used in power plants are setups type transformers used for raising the voltage from electric generator so that electric power can be transmitted over long distances economically. So this is the working of transformers step by course used to raising voltage. They transfer the voltage through transmission lines for economic use. Okay. Now this is the owner. These are the major lists of power plants in India. Okay, so here Maharashtra SEB location Durgapur, Maharashtra, and total capacity megawatts is 2340. Then Neyveli Lignite Crop Corporation Limited, that is situated in location Neyveli, Tamil Nadu, and 2280 megawatt capacity. Then NTPC Siddhi Madhya Pradesh, it produces 2260 megawatts. And NTPC Bilaspur Chhattisgarh, which produces 2100 megawatt. And NTPC Karimnagar district Andhra Pradesh, which produces a total 2100 megawatt. Okay, so thank you, bye bye, have a great time.